Friends, do you know nanotechnology? It is a novel thing in the modern world. It is a part of science and technology about the control of matter on the atomic and molecular scale. This means things that are about 100 nanometers across. Nanotechnology includes making products that use parts this small, such as electronic devices, catalysts, sensors, etc. To give you an idea of how small that is, there are more nanometers in an inch than there are inches in 400 miles. To give you an international idea of how small that is, there are as many nanometers in a centimeter as there are centimeters in 100 kilometers. Nanotechnology brings together scientists and engineers from many different subjects such as applied physics, materials science, interface and colloid science, device physics, chemistry, supramolecular chemistry, which refers to the area of chemistry that focuses on the non-covalent bonding interactions of molecules, self-reflecting machines and robotics, chemical engineering, mechanical engineering, biology, biological engineering and electrical engineering. Generally, when people talk about nanotechnology, they mean structures of the size 100 nanometers or smaller. There are 1 million nanometers in a millimeter. Nanotechnology tries to make materials or machines of that size. People are doing many different types of works in the field of nanotechnology. Most current work looks at making nanoparticles that have special properties such as the way they scatter light, absorb X-rays, transport electrical currents or heat. At the more science fiction end of the field are attempts to make small copies of bigger machines or really new ideas for structures that make themselves. New materials are possible with nano-sized structures. It is even possible to work with single atoms. There has been a lot of discussion about the future of nanotechnology and its dangers. Nanotechnology may be able to invent new materials and instruments which would be very useful, such as in medicine, computers, and making clean electricity, nano electromechanical systems. It is helping design the next generation of solar panels and efficient low energy lighting. On the other hand, nanotechnology is new and there could be unknown problems. For example, if the materials are bad for people's health or for nature, they may have bad effect on the economy or even big natural systems like the earth itself. Some groups argue that there should be rules about the use of nanotechnology. There is the start of nanotechnology. Ideas of nanotechnology were first used in talk. There is a plenty of room at the bottom. The talk given by the scientist Richard Feynman at an American Physical Society meeting at Caltech on December 29, 1959. Feynman described a way to move individual atoms to build smaller instruments and operate at that scale. Properties such as surface tension and van der Waals force would become very important. Feynman's simple idea seemed possible. The word nanotechnology was explained by Tokyo Science University professor Norio Taniguchi in a 1974 paper. He said that nanotechnology was the work of changing materials by one atom or by one molecule. In the 1980s, this idea was studied by Dr. K. Eric Drexler, who spoke and wrote about the importance of nanoscale events. Engines of creation. The coming era of nanotechnology, 1986, is thought to be the Will Trust book on nanotechnology. Nanotechnology and nanoscience started with two key developments: the start of cluster science and the invention of the scanning tunneling microscope STM. Soon afterwards, new molecules with carbon were discovered. First, fullerenes in 1986 and carbon nanotubes a few years later. In another development, people studied how to make semiconductor nanocrystals. Many metal oxide nanoparticles are now used as quantum dots. In 2000, the United States National Nanotechnology Initiative began to develop science in this field. Nanotechnology has nanomaterials which can be classified into 1, 2 and 3 dimensions nanoparticles. This classification is based upon different properties it holds, such as scattering of light, absorbing X-rays, transport electric current or heat. Nanotechnology has multidisciplinary character, affecting multiple traditional technologies and different scientific disciplines. New materials which can be scaled even at atomic size can be manufactured. 1 nanometer is 10 upon minus 9 or 0.000000001 meter. When two carbon atoms join together to make a molecule, the distance between them is the range of 0.12 or 0.15 nm. DNA double helix is about 2 nm from one side to the another. It develops into a new field of DNA nanotechnology. In future, DNA can be manipulated that can lead to new revolution. Human genome can be manipulated according to requirements. A nanometer and meter can be understood as the same size difference as between gold ball and the earth. 1 nanometer is about 1/25,000th the diameter of a human hair. Fingernails grow 1 nanometer per second. At nanoscale physical properties of system or particles, there are physical characteristics of nanomaterial. Physical properties such as quantum size effects where electrons move different for very small sizes of particle. Properties such as mechanical, electrical and optical changes when macro system changes to microscopic one, which is of utmost importance. Nanomaterials and particles can act as catalysts in increase the reaction rate. Along with that, produce better yield as compared to other catalysts. Some of the most interesting properties when particles gets converted to nanoscale are substances which usually stop light become transparent. Copper. It becomes possible to burn some materials. Aluminum. Solid turn into liquids at room temperature. Gold. Insulators become conductors. Silicon. A material such as gold which does not react with other chemicals at normal scales can be powerful chemical catalyst at nanoscales. These special properties which can also see at the nanoscale are one of the most interesting things about nanotechnology.
Thanks for watching.